All right, here we go. Here's the test we're going to go over, and we'll start right at the beginning, number 1. And this one, I tell you, I know I say this a lot about, I think problems are kind of easy, and I get accused many times by students. Mr. Hamrick, you say everything's easy. Is there anything that you think is difficult? Yeah, of course there is. But I think this one is probably the easiest problem that you're going to do the whole entire year. I really do. I don't think there's any problem that's any easier than this. And I still got people that got it wrong when we took the test the first time. Watch how easy this is. Some of you guys made this way more complicated. You looked at this and you said, oh, we got a foil, we got a foil. But look, these are all being multiplied, these are all being multiplied. Look to see if anything cancels out. Does anything cancel out here? Yep. Yeah, the n plus 7. Bang, bang. You're done. Just write it, you know, without all the stuff. But that's all you had to do. That's all you had to do. So don't miss this. If I have this on the midterm, I don't know if I do or not, but that's it. Right there. Would you agree? That's probably the easiest problem that we're going to do all year, that we have done, or we're going to do. Yeah, I doubt you could find one that's any easier than that one. So there you go. That's how you do it. Let's do this one. Okay, here we go. Now this isn't quite so easy, but eventually it'll boil down to basically what we just did on number 1. If you look at this, what do you think what is your first reaction to do? Or what is it to do to this problem? It's to factor it, isn't it? I hope that's your first reaction, because it's a trinomial, so we just do trinomial factoring. So we put a little parentheses here and here, do the same thing down here on the bottom, and then we factor it. So this is an r. These are pretty easy factorings because you got a coefficient of 1 out in front. So you put an r and an r. They multiply to be negative, so that means one has to be positive and one has to be minus. Everybody see that? And now it has to multiply to be negative 10, and they have to add up to be positive 3. So what do you think you're going to use? Yeah, 5 and 2, right? Because 10 and 1 you can't get a 3 out of it, but 5 and 2 you can. The 5 has to go with the plus, and the 2 has to go with the minus. Because when you multiply them together, it's negative 10. When you add positive 5 and negative 2, you get a positive 3. Alright, so that's how you do trinomial factoring. Let's do the same thing down here. Now, when they multiply, they have to be positive, but when they add up, they have to be negative. That means you're going to have one negative and one negative. What times what? What do you think you're going to use? 2 and 2, right? So negative 2 times negative 2 is positive 4, and then when you add them up, negative 2 plus negative 2 is negative 4. So there you go. So you did have to do a little bit of work, but once you get to this spot right here, then it's exactly like number 1, isn't it? So see if anything cancels out. Anything? Yeah, r minus 2. You got an r minus 2 on the top, you got an r minus 2 on the bottom. Doesn't matter which one you cancel out here, does it? Because they're both exactly the same. And that's your answer right there. You probably want to rewrite it without all that mess around it, but that's your answer. We good? Alright. All you had to do is know how to factor, a little trinomial factoring, cancel a couple things out. Not that big of a deal. Let's move on. Alright, we're going to do kind of the same thing as we did before. We're going to look to see if anything cancels out. Okay, that's the best thing about multiplying fractions. I always look to see if anything cancels out. Is there anything on the bottom that divides evenly onto something on the top? Now look, everything's being multiplied on the top, everything's being multiplied on the bottom. So I'm allowed to cancel out. Remember I had a big talk about that before, like if you had something added, it wouldn't cancel out. Alright, but this thing, everything's being multiplied. So if I can cancel things, I'm going to cancel things. That's the easiest way to do it. Don't go 3 times 20. Alright, don't do that. Alright, a lot of you guys, not a lot, I keep saying that. Not a lot, but I remember 1 or 2, okay, at least several. Probably tried to make this more complicated. Look how easy this is. Let's do the numbers first. Are there any numbers that divide out, that cancel each other out? Well, the numbers, just the regular numbers. The 4 and the 20, right? 4 goes into 4, what? 1 time, and 4 goes into 20, 5 times, right? You learned that as a little kid, didn't you? How to cancel things out when you reduced fractions and that kind of thing. Now we can go ahead and do the variables, okay? Because there's no other numbers that cancel out. What about the variables? Look at this. I have an a squared on top and an a cubed on the bottom. Now a lot of people say, well, let's subtract the exponents. Yeah, you could do that, but then you're going to get a to the negative first, and let's start looking ugly. But go ahead, Morgan. What were you going to say? That's right. So a squared, look, I got 2 a's up here, don't I? And I got 2 a's down here. But how many cancel out? 2 of those cancel out. How many am I left with, I should say? Just 1a. Everybody see that? I've got 2 up here. It would be like this. In your head, you're thinking this. Does that make sense? That's a squared, that's a cubed. So look, that cancels with that, doesn't it? This one cancels with this one. What are we left with? An A down on the bottom. Agreed? All right, let's make sure we get that because that really comes in handy, All right, now the A doesn't cancel out, right? Because we still have an A right here. So it's not like the A cancels out. It's an A to the first. So let's see what's on top. I got a 3 on the top and I got a 5 on the top. They're being multiplied, so that gives you a 15. On the bottom, it's a 1 times an A, which is just A, and there's your answer right there. Wasn't a real difficult problem, but there are problems that could be a little more challenging than this, but the process is the same, all right, as far as canceling things out. Get used to that, all right? It's really not that bad. There I go again, saying these problems aren't that bad. Sorry, apologize if I say everything's easy, but once you know how to do them, really, once you know how to do any kind of problem, it's kind of easy, right? Problem is learning how to do it in the first place. All right, let's do number 4. If you look at this one, this is not a multiplication like this one was, but it kind of is, isn't it? Remember your little kid when you did fractions and we learned about division? We never really divided fractions, did we? We always turned it into a multiplication problem, and that's exactly what we're going to do right here. Okay, we're going to take this division. Watch this. My fancy computer here. We change it to a multiplication, but you can't just change that to a multiplication because that's not the same thing, is it? So I completely changed a division into multiplication, so what am I going to do to this thing right here? I'm going to flip it. That's right. So watch this. I'm going to take this. Isn't that cool? So watch. I can take the bottom, put it to the top, and take the top one and put it on the bottom. What's the technical term for that? Multiply by the reciprocal. Okay? That's the very first thing I would do. In fact, I'd probably write it down. I probably wouldn't even write it. When I wrote it first down, I probably wouldn't even write it down as a division. I just did that so you could see what the problem looked like. But then I would multiply by the reciprocal, and you flip the top and the bottom. So that's definitely your first step. Don't do anything else before you do that. Now what we have to do is factor. So let's do that. We got trinomial factoring on the top and the bottom here, and we'll do this one in a second. Let's do this first. So it's R and R. Let's see, 9 times 4, right? Is 36, and it adds up to 13. They're both positive, so 9 and 4. All right, R and R. 72. I mean, what do you think? 9 and 8? Yeah, 9 times 8 is 72, and 9 plus 8 is 17. So 9 and 8, both positive. Pretty easy factoring. Let's come over here and do this. Tiffany said this earlier when we were writing it down. What kind of factoring is this thing? It's a difference of 2 squares. That means one's going to be positive, one's going to be minus. One's going to be negative. You've got R and 8. Yeah, you got R and 8. Why did I pick 8? Because 8 times 8 is 64, isn't it? Everybody see that? This one right here. Now this is not a difference of 2 squares. But it's just a greatest common factor. It's the only way we can factor this bottom right here. Okay, it's not a quadratic or a trinomial factoring. Well, technically is a quadratic, but it's not one of those trinomial factorings. You just factor out a greatest common factor. So you factor out an R, and what are you left with? R plus 4. That was the work. Okay, that was all the work. Now the fun part. This is the part I enjoy. Watch this. Bang, bang. They go, don't they? Right? Whop them off. And we can do that, can't we? Because all this stuff up here is being multiplied. Even though you have pluses inside the parentheses, that parentheses is being multiplied by this parentheses, by this one, by this one. So we can knock things off like this. Everybody got it? What else can you knock off? R plus 4. Bang. Bang. They go. It's like you're shooting ducks off a fence. All right? Never done that before, but I can imagine. It's just like that. So watch this. R plus 8. Bang. Bang. They go. Is anything else? What about this R right here and this R right here? Can I cancel out those R's? No, because this R is it's inside this parentheses, it's part of a subtraction problem. So this R and this R don't cancel out. So really, what am I left with? Just R minus 8 over R, and that's my answer. So if you know how to factor, the simplifying part's not the hard part. That's the easy part. That's the fun part. I enjoy doing that one. Don't you? Does anybody? Well, you don't have to be a math person to enjoy it. Let's do another one. It looks kind of like this.
Type of person that enjoys math.
Oh, well, my goodness. Must be something wrong with you if you don't enjoy math, I'll tell you.
Okay, there must be something wrong.
Okay, here we go. This looks pretty much the same thing, doesn't it? So let's go through this real quick. So we're going to factor all this. Now, I don't have to multiply by the reciprocal this time, do I? Because it's just a straight up multiplication problem. So I don't have to flip anything. So I just factor this thing. So what do I get? P and P, plus and plus. What do you got? 8 times 5? Is that right? Yep. 8 plus 5 is 13. So I've got an 8 and a 5. Are you getting pretty good at this trinomial factoring now? Oh, this looks familiar, doesn't it? It's the same exact thing. 9 and 8, right? Or you can go 8 and 9 if you want to put it right underneath it there. Let's do the top. This is greatest common factor, just like we did on the other one. Wow, this is almost an identical problem, isn't it? And this right here, got a P and a P right here, got plus and a minus. 35, 7 and 5, right? 7 is going to go with the negative, and 5 is going to go with the positive, because when I add them up, it has to be a negative 2, right? So the 7 has to go with the minus. The bigger number has to go with the minus. All right. Let's whop things off now. That goes, P plus 5 goes, P plus 9 goes. Look at that. Almost an identical problem. Didn't realize they were that close to each other, but there you go. 2 shots at it. I guess that it could be good or bad, right? If you got number 4 right, you probably got number 5 right. But if you missed number 4, you probably missed number 5. So I usually try to, I don't know why I put 2 problems on there that are so similar to each other. Usually I try to mix them up just a little bit. But that's how that goes. Number 6. Now this one, you know how I've been saying, oh, that was easy, that was easy, that was easy. This one's a little bit tougher, all right? So I'll give you that. First thing we're going to do, now look what we're doing here. We're subtracting this time, aren't we? We're not multiplying, we're not dividing, we're subtracting. And even back when you first learned fractions when you were a little kid, wasn't addition and subtraction a little bit tougher than multiplication and division? I think so when you did fractions. Because you have to find common denominator, and you didn't have to do that with multiplication and division. So first thing we're going to do, we don't like the form that these denominators are in right now. So what does it look like? We've been doing this a couple times already today. What does it look like we might be able to do to this denominator and to this denominator? Give me one word. Come on. Factor, right? Factor it. So let's do that. This is a difference of 2 squares. So we're going to write it like this. One's plus, one's minus. We got x and x, and we got 4 and 4. So you should be able to factor that. Put a minus, and then you should be able to factor this thing as well. This is really easy factoring. Okay, so factoring was not, should not have been the struggle here. So if you factor this, they're both plus, and 4 and 1 will give you 5. So 4 and 1. All right, that's a much better way to start off trying to find the common denominator. Now what you have to do is you got to look at this. We've talked about this before. Remember, if I had like a 8 and a 12, and I wanted to find the common denominator, do you remember what we did with this? I broke it down into its primes. Would you agree? Then I broke this down 4 times 3, right? Which is 2 times 2 times 3. Remember what I told you to do? You pick the numbers that show up here, right? I got 2 little columns here. Look what I have here. Look at the 2's. I've got 3 2's here, and I got 2 2's right here. Well, if it shows up more in one place than the other, I take the one that shows up more number of times, the most number of times. So I take 3 of them. What other number shows up here? Come on, talk to me, please. What other number shows up? I got 2's and I have what else? A 3. Okay, I got a 3 here, and I don't have any 3's here, so what do? I pick one of them, right? Now, what do I do to find my common denominator? Multiply all those things together. So this is 8 times 3 is 24. So that would be your common denominator with 8 and 12. Does that make sense? That's what we did. We've talked about that on several occasions. Hopefully that makes sense to you. I can't explain that anymore to you. So look at this. Let's see what we have here. And also, let's say I had, I could have picked different numbers here, but let's go back to this. Now look what we have. This is kind of like split it like this. All right, I'm looking at, I got these 2 and I've got these 2. So let's see what shows up. Well, I got an x plus 4. Do I have an x plus 4 over here? Yeah, I do. I have 1 here and I have 1 here. So how many do I pick to find my common denominator? I just pick one of them, okay? Even though it shows up in both spots, once here, we only pick one of them. So I'll circle it. We just pick one of them. What else shows up? X minus 4. Now, we don't have one over here, but is that okay? Yeah, it's fine, because we had a 3 here and we didn't have any here, did we? All right, so we have an x minus 4, so we pick one of those. What else shows up? An x plus 1. There's none over here, but there is one here, so we pick that. So what's our common denominator? What do we do with those three things to find our common denominator? We just multiply them all together. Now, when I say multiply them all together, I'm just going to stick them next to each other. That's still multiplied together, isn't it? I'm not going to actually multiply all three of these together and get some, crazy thing. So now, what do we have to do? Let's get rid of these circles. Got to change the numerators, right? We've got to find what the new numerator is going to be. So let's take a look. What did we do to this to get to that? Well, we already have an x plus 4. We already have an x minus 4. What are we missing? An x plus 1. So if I multiply the bottom by x plus 1 to get to this, what am I going to have to do to the top? Multiply the top by an x plus 1. All right? It's just basic rules for finding common denominators with fractions. It's a little more complicated, I agree, completely understand, but it really boils down to the same basic rules we've always used. What about this? What did we do to this thing to get to our denominator? X minus 4, right? Because we already have an x plus 4, we already have an x plus 1. What we're missing is an x minus 4, so we multiply that by an x minus 4. So let's go ahead and do that multiplication and see what we get. Now, I could just sit here and write x times x plus 1, but let's go ahead and actually multiply that through. All right, so let's multiply it through. It's distributive. That's why I put this in parentheses. So I get x squared plus x. Now, I have to be very careful with this, because what is in between here? It's minus, isn't it? So really, it's a negative 8. Even though that 8's kind of pushed over a little far away, it's still a minus 8. So when I distribute, I have to distribute the negative 8 through both of these things. So it's negative 8 times x, which is negative 8x. And it's a negative 8 times a negative 4, which is a plus 32. Hopefully that made sense to you. Write it down. Go back and look at the video if I went a little quick for you. So now you just simplify that. That's all you do. Okay, so let's just add like terms. Basically all we're doing is just adding these like terms together right here. So my answer is x squared. Whoops, I was going to put a plus, but it's not. Positive x minus 8x is negative 7x plus 32. And that's over all this stuff right here. X plus 4, x minus 4, and then x plus 1. Don't multiply the denominator all out. Just keep the denominator exactly the way it is, like this. And that's it. You're finished. Okay, this doesn't factor, all right? Now, you'd look at it and try to factor if it does. I don't think it does it? Nope. 8 4 is 32. 16 times 2. No, you'll never get a negative 7 out of that. So you're done. That's your answer right there. A little bit more complicated, okay, especially because a lot of people don't like fractions. I get that. But you still need to know how to do them, even though you don't like them. Like Tiffany said, not everybody likes math, but it's very important that we learn how to do it. All right, just because we don't like it. There's a lot of things that we don't like that we still have to do. All right.
I'm pretty sure you don't like taxes.
You're right. I don't like taxes.
Sorry, just throwing examples out there.
But taxes are necessary to make the world go round, I guess, right? But I think we overdo it in this country with taxes. I was listening to Ellie have a conversation with somebody in study hall, and he was saying, oh, well, in Canada, we get free health care. We don't have to pay for anything. I'm like, yeah, but their tax rate's like 3 times the amount as what our tax rate is here. Well, maybe not 3. It's at least double, I think, what it is here. So they are paying for it. So, and I didn't jump in the conversation and say anything, but it's true. And their healthcare system is, as bad as we think ours is, theirs is pretty rough. So anyway, get what you pay for, right? So here we go. Let's do the same thing. I got 10 and 14. This is a good thing that we're doing this because, watch this. I'm going to put a 10 and a 14 here. Let's find the common denominator with this. You might be able to do it in your head, but if you can't, let's do it this way. Break down 10, which is 2 times 5. Break down 14, which is 2 times 7. How do we find our denominator? I got a 2 here and a 2 here. So it only shows up one time, doesn't it, in each place. So I just pick one of them, right? What about the 5 and the 7? Well, 1 5 shows up, so I just pick one of them. This is a little closer to that last problem we did, right, with the parentheses. Probably should have used these numbers instead of using that 8 and 12 thing. But anyway, I've already picked a 2, so I'm not going to pick a 2 here. What else shows up? A 7. It only shows up once, right? It only shows up once, so I pick those. So let's multiply all that together. 2 times 5 is 10, times 7 is 70. So that's our common denominator with 10 and 14. But we also have the p and the p squared. So remember what we do? I've got a p here and I got a p squared. P squared is p times p. I've got p's on both sides, but what do I pick? I pick the one that shows up the most number of times, right? So this would be what? P squared. So that's your common denominator right there. Again, I know I went quick, but, follow along on the video. What'd you do? What'd you do to this to get to this? What did you multiply this by to get to that? You multiplied it by a 7, right, to get from 10 to 70, and you multiplied this by a p. So what do you do to the top? Multiply it by the same thing, which is a 7p. Do the same thing here. What did you do to this? What did you multiply that by in order to get to that? 14 times what? 5. That's right, 14 times 5. And then did you do anything to the p squared? Nope. So all you did was multiply that by a 5. So you come over here and you multiply that by a 5 as well. Is that making a little more sense now? Okay, so let's figure out what we get here. 3 times 7p, which is 21p. Plus, what's this? 9 times 5, which is 45. And that's it. Yeah, you can't do anything else with that, can you? Nothing. I mean, there's a 3 that divides evenly into that, but 3 doesn't cancel out with 70, so there's no reason to factor out a 3 here. And that's it. You can't simplify it any more than that, so you just leave it like that, and that's your answer. All right, number 8. Let's go with this mochaccino. Is that what they call it? Mochaccino. Number 8. Oh, it kind of looks like that other one, doesn't it? That's okay. Let's try another color. What haven't we used? We use this purple. Alright, look at this crazy thing. X over 3 over 4 over x plus 4. This thing doesn't quite look like a 4. Let's make it look more like a 4. There we go. Well, what is a division problem? What is a fraction? I gave it away. That really means to do what? It means to divide. We talked about this earlier, didn't we? About dividing. We don't really divide fractions at all. We always change a division into a multiplication. We multiply by the reciprocal. So look at this. This is the top. All right, that's our first thing. So it's this divided by this. It's the top divided by the bottom. So we don't really write it as a division problem. We write it as a multiplication problem. But we said this word earlier today. We multiply by the what? Reciprocal. So I put the x plus 4 over 4. Reciprocal. Everybody understands that, I hope. Just flip the fraction. All right? And let's see. Does anything cancel out? Does this 4 cancel out with this 4 right here? No, it doesn't, because this 4 is being added to this x. So it doesn't cancel out. So what I would do, I would just write it like this. We're basically done here, aren't we? X times x plus 4. Now, if you wanted to multiply it out, that would be okay. It wouldn't be wrong. But if you wanted to keep it like that, that would be fine as well. All right? I would just let you keep it like that if you want. Or if you wanted to, put a or right here. You could say x squared plus 4x over 12. I would keep it like that, to tell you the truth. Either way, I really don't have a preference, to tell you the truth. I'd be okay either way. All right, that was easy. There I go again. But that was easy. You got to agree with that, don't you? Yes. Nobody talking to me? You mad at me or what? All right, let's do this one. Oh, this one's real crazy looking. All right, look at this monstrosity. Well, at first it looks real crazy, but let's break it down into things that we can actually do. Let's do this first. See this m? I'm going to put it over 1. I just think it looks a little nicer if I do that, right? So it looks like a fraction. So what I'm going to do first is I'm going to think about adding these two fractions together. But before I do that, I have to find a common denominator, okay? And so let's take this, we did this earlier, right? And find a common denominator with that. And I'll just off to the side. What's your, if I factor that, what are you going to get? M plus 6, m minus 6. Very good. So let's rewrite it like that. So it's going to be 5 over m plus 6 and an m minus 6. They've rigged this thing, haven't they? Because look, you got an m minus 6 here, you got an m minus 6 here. You know something's going to cancel out, wouldn't you? Wouldn't you think? All right. So plus m over 1. Well, what's our common denominator? I'm just doing the stuff in this box up here first. Then we'll worry about the bottom. Don't forget about the bottom.
Plus 6 minus 6.
Yeah, it's just the same thing, right? This is over 1, right? So the denominator is just m plus 6, m minus 6 again. So the denominator is exactly the same, but I do have to change one of the numerators. I don't have to change this one because I didn't do anything to that, did I? What am I going to have to do to this to get to this? I'm going to have to multiply everything, aren't I? Which is m plus 6, m minus 6. Would you agree? Actually, I'm going to scooch this down. Kind of. All right, so let's write this as a nice one big fraction. So I've got an m plus 6, m minus 6 on the denominator.
Question, can you put the 5 plus m in parentheses too?
Well, you're going to put a 5 here, and then you're going to put a plus. And then, I think we you know what? Did we leave it like that? What's that? Right. Yeah, we're beyond that though. We're fine just putting a 5 here. But I'm thinking about this right here. Did it matter that we multiplied it out? I guess it did, right? Because we'll get a will we get a constant out of that? Did I multiply it out when I did this, or did you multiply it out? I'm just trying to think of the best way. Okay. So you already know what this was, right? What was it? That was m squared minus 36. So we're just taking m times this. So what would that be? It'd be m cubed minus what? 36m? Okay. Yeah, I guess that's the best way to do that. All right. Now remember, don't forget about this thing right here. So we're not finished, are we? We have to divide that by 1 over m minus 6. That is what it was, right? Yep, 1 over m minus 6. But remember, we don't do division, do we? We multiply by what? The reciprocal, m minus 6 over 1. And now, look, this m minus 6 is being multiplied by this whole thing right here, so I must put that in parentheses. See what we can do here? Bang, bang, right? And I'm done. Just write 5 plus m cubed minus 36m over, and then it's just m plus 6. That's the answer. Now, if you wanted to rearrange the top, that's fine. Didn't have to be in that order. It just happens to be in that order. That is the answer that you got, right? Or that I wrote down? Yeah. You could have written m cubed minus 36m plus 5 if you wanted to, just to get that 5 over here so it's in a nice order, but that's fine just like that. I'm good with that. All right. We could probably get 2 more done, I think. So, yeah, these are pretty simple, so it should be pretty quick. 10 is 1/2 to the -4th. It's not hard to do, you just have to remember what to do, right? That's pretty much all math is. You just have to remember what to do. This is being taken to a negative exponent. So if it's being taken to a negative exponent, I could take this whole thing, flip it to the bottom and all that stuff. But since it's a fraction, instead of flipping the whole thing to the bottom, I could just take this fraction and flip the fraction, right? So if I flip this, what do I get? A 2. But since I flipped the fraction, I got to change something here. What do I have to change here? Make it to a +4, all right? That's basically the same thing as flipping it to the bottom and changing the sign of the exponent. Except I didn't flip it to the bottom, I just took the inverse of the fraction, reciprocal the fraction, and I got this. 2 to the 4th is 16. Simple as that. Number 11. This is the same process. The same process. It's a little bit tougher because they threw a little extra thing in here, but our first step is exactly the same. I've got a negative exponent, so what am I going to do with this stuff right here? I'm going to flip it, so it's 25 over 4. If I flip the fraction, I got to change the sign. I'm only changing the sign of the exponent, so it's to the +3 over 2. Now look at this. You got +3 over 2 right here is a little easier, but now it's a little more difficult. But if you remember what we did here, we split this up into 2 parts. We went 25 over 4 to the 1/2. Then you took that whole thing and took it to the third, right? Because if you look at it, what's if I take something to the 1/2 and then to the third, the rule says I multiply those exponents, right? So it's the same thing. It's the exact same thing as this. But why did I do this? This is rigged again, isn't it? I mean, they definitely rigged this thing. They didn't just, come up with random numbers. I mean, they made this so you could take the square root of it. And when I take something to the 1/2 power, I'm taking the square root. So I'm taking the square root of 25, which is 5, taking the square root of 4, which is 2, right? So that took care of all that, but all this is taken to the what? Third power. Now we can take all this stuff in here and cube it. 5 cubed is 125. 2 cubed is 8, and I'm done. Few steps, not very difficult steps. Practice it, all right? I'll say it again, all right? Whether or not you're internalizing this or not, you've got to practice these problems. I could sit here and give you the best explanation that was ever given on these problems, and that's not going to do a whole lot for you. It'll help a little bit, but it's not going to do everything for you. You have to do these problems yourself, okay? You've got to do these. I'm not giving homework all week, but that does not mean you shouldn't be doing problems this week. You should be doing problems on your own, okay?